Okay, now it works. Hello, good morning, everybody. I admire and appreciate your being here. It's weekend and it's pretty early. I usually sleep at this time. So thank you for being here. I'll try to entertain you as much as possible as my token of appreciation. So my name is Baruch. I'm a developer advocate with JFrog. No changes from yesterday. We still produce awesome t-shirts. And if you like this t-shirt, we still have a lot at our table there. So after this talk, we can go there and give you some swag. Also stickers. We also have stickers. I'm done. No, we do other stuff as well. So we have 4 awesome products that we'll be more than happy to talk to you about them at our booth. Artifactory, which is a universal artifact repository, and Bintray, which is a universal distribution platform, Mission Control that controls Artifactory and Bintray, and X-Ray, which is a universal component analysis tool, brand new, very exciting, and apparently quite useful. But that's at the table. Now I want to do something funny. Now, but it says poll here, but it's actually a social experiment, because when you run a poll, you expect to learn something new. Here, it's different. I know exactly how you're going to vote, and I just want you to see it. So that's the whole purpose. And we're doing by the show of hands. Who heard about Docker? And you keep your hands up. You keep your hands up. And now, who can do the tutorial? Yes, most of the same people. Good, good, good. How about playing with Docker at work? POCing, this kind of stuff. Same people, 80% from of the audience. Good. And now the magic happens. Who uses Docker in production? 1, 2, 3, 4, 5 hands. The question is why? And there are a lot of theories why we have that. The obvious reason is Docker is this obscure layer of indirection that we're not really sure what's going on. And we place it, and then the tutorial works, and we can get the hello world, and then they have some word game, right? What it was like. They have something in the tutorial pretty fun, and we feel good about it. But then when we take this simple tutorial and try to apply it to our complex systems, the fear kicks in, right? Because we are really not sure what's going on. And this lack of trust is exactly what brings this difference between how many people play with Docker and how many people actually dare to take it to production. And what we at JFrog this is what we try to fight, and this talk is about how can you trust your Docker a little bit more, and hopefully by applying those principles that we are going to talk about today, take it eventually to production. Right, so JFrog have a long, loving history with Docker. We pioneered the concept of proper image management in terms of binaries. We did Docker registry before there was a Docker registry, just for you to understand where we stand. And that's because this is what we do. We manage binaries, and Docker images, for that sake, is the same. So Artifactory can be used as a Docker registry instead of Docker trusted registry, and we can go back and forth comparing them and claiming that they have this feature and we have that feature, and this is better with Artifactory and this is better with Docker trusted registry. But there is one thing that is undeniable, and here I will run this social experiment once again. This is Solomon Hykes, the creator of Docker, of course, speaking at the keynote. I took this picture at the DockerCon last year, 2015, in San Francisco. And he asked exactly this question: who is using Docker and nothing else? And just for you to understand what he means by that is, you have an organization that the only type of artifacts you have there are Docker images. So who is using Docker and nothing else? Exactly, no one. That's true for you, that's true for thousands of people at DockerCon, that's true for everybody, because this analogy of container actually makes a lot of sense. Docker is a containerization technology, and shipping back and forth empty containers, it's a pretty stupid and not very profitable business. No one does it, you don't do it. You always have something. Who ships Java in their Docker images? Docker containers, right? PHP, Ruby, Python. You got the idea. You always have something inside. And if you take Docker Trusted Registry for your Docker images, you will have to have another solution for managing other packages. If you take what we do, like Artifactory and Bintray, they are universal. You can have one tool to rule them all. And the important thing is not only I have one less server to manage, which is a big deal, but not really big deal. It's about having a traceable metadata across different packaging types. Knowing how you ended up with this Docker container all the way back to how this image was created, how the Debian package inside was created, how the WAR file inside was created, and how the jar file inside was created, and being able to trace all that back and forth. And that can only be done if you use a single tool. We're going to talk about that. So back to our question about patterns and anti-patterns in container lifecycle, in establishing continuous integration and continuous delivery, the question is, with software industry is, do we already have a pattern and how we should adapt it? And the answer of, do we have a pattern of continuous integration and continuous delivery is, hell yes. We do it for years. And what I'm going to talk with you about the next 2 minutes shouldn't be new to any of you, maybe except a couple of students that get started with computer science. For the rest of you, it should be obvious. So what we have is this very strange diagram, which I kind of miss enough dimensions on the slide to express what I wanted to say, but I'll try. So here we have builds. The different stages in our continuous integration, the development, the dev integration, the integration, staging, production, and pre-production, less and less builds survive when they go through this process. And that's why those getting thinner. But the time that it takes to perform the test increases. So unit tests, we have a lot of them, but they're very short. System integration or staging tests are very long, but we always have no builds that survived to that level, right? And another way to express that is this diagram. I love it much more because I didn't do it. And that's for a great book that's called Agile ILM. It's an old book, I think it's 10 years old already, but it's still very relevant because nothing changed. This is how we do continuous integration and delivery. What you see here, those number 1, 2, 3, and 4, are what is called quality gates. And the whole pipeline of promotion in your continuous integration is promoting artifacts from one environment to another through those quality gates. Does it make sense? It does. Do you know it? You do. Good for you. That's exactly what's going on. Now, the interesting part is we all know that, and we don't do it for Docker images. And the question is why? And the answer is that. Docker build command is the problem. And the problem with Docker build command that it's extremely powerful and extremely simple. And being extremely powerful and extremely simple makes us want to do that. We always want to run to Docker build because actually creating a pipeline of a text file is so much easier than creating a pipeline of binaries. All we need is Git with some branches, and we're done. We will mark the Docker file as different stages in our pipeline: dev, system test, staging, production, and based on the location of this Docker file in the branches, we know exactly what to do. And then we can run the Docker build on every environment and get our pipeline very simple and very fast. The problem is, fast and cheap builds are not always the way to go. So the problem that this approach of promoting the Docker build is failing is because of that. Now, when I prepared this talk for the first time, I wanted to compose the, like ridiculously unstable Docker build file. And I said I will add a disclaimer that actually no one does that, and this is just to drive my point home. And then I went to the internets and discovered that, hell, this is how people write their Docker images for production. I don't need to invent anything. The reality is much worse than my wildest dreams. Every line in this Docker file, except of line number 5, which is creating a directory, and line number 9, which is running the app, is a dependency management relying on latest version. And this is horrible because chances that I will end up with the same image running this file a couple of times over a couple of days are tiny. And if I promote this Docker file and create image in each and every different environment, I will end up creating, testing, staging, and running with production with different images. So the question is, can we fix it? Oh, and I wanted to throw t-shirts on you for correct answers, but I forgot to bring the t-shirts. Okay. Oh, here we go. Leonid, thank you very much. Just grab a bunch. Okay, so can we fix it? Let's start with the from statement. Can we fix the from statement? Yes, hell yes. How can we fix the from statement? 1604. Thank you very much. You get a t-shirt, they bring it, I will throw it on you. Good choice. Thank you very much, guys. Okay, so now my football skills, which are horrible. You see? My son is better than me. Yeah. All right. So is it better now? No. Leonid, you got a t-shirt. No, wait. Why it's not better now? You heard this talk, didn't you? Okay, let's pretend you didn't. Okay, so here's an interesting dilemma from the canonical guys, the creators of Ubuntu. From one side, we all know what a release version means. It means it shouldn't change. Whenever we will try to download the 1404, we will get the same version. From the other side, there are those, we call them Devops Engineers, system administrator guys, and what we know about them, they hate change. Right? If they found a good version, and 1404 was a very good version, they will never, ever, in their life, upgrade. Am I right? I'm talking about you guys. You recognize yourself? It will screw up the uptime. We cannot do that, can we? But what happened between April 14 and today? Well, that's not what I meant. What happened between April 14 and today? What are you going to do with all those t-shirts, Leonid? Heartbleed happened. And here's the dilemma. We want to rely on versions, but on the other side, we want all of you to get this critical security fix. And here's the trade-off. And Canonical probably did the right thing. And 1404 as of today is not the 1404 as of April 14. So this won't fix it. Any other ideas of how we're going to fix it? Yes. Here you go, image hash. I didn't pay them, seriously, I didn't. Because, here you go. Is it better now? No, why not? Who said unreadable? First, here you go. Well, do you know which version I refer to now? No, no one does. Is it actually a real, like, hashtag? Or I just sat on my keyboard and that's... Can we make it an ARG? Oh, yeah, no, we can't. Right? But that's completely unusable. So that's one problem. Right. How about these? Are they fixable? Yes. Why they are fixable? Of course. apt-get, we know it. We know it because we all use and love our apt-get. We know we can actually nail down the versions. And those are application versions, and chances are they will be solid. But that's just because we know how apt-get worked. I just delivered the very similar talk with the same pitch at Silicon Valley Code Camp when my audience was pure developers, no DevOps guys. None of them had any idea what apt-get is, and they sincerely didn't know, can we put a version in apt-get or not? And none of you are Java developers, except a couple of hands that I showed earlier, and I will ask you, what if line number 4 was run mvn install? Or maybe yes. Maybe it's great. Maybe you have a POM file which nails down all the versions. And how about run update depths.sh? My point is, there is no way to make this Docker file stable. Not in the world, because it's super powerful and super simple. This is what we end up with. We run Docker build on the same Docker file, and we end up with different images, and that's exactly why we don't trust Docker. There is a way out of it, and it comes from another pattern that we all know and love, and that's the immutable server pattern. And thank you for the Netflix guys for popularizing it. We actually took it from their blog. From Martin Fowler, as most of the good patterns we know. And it talks about if you need to change something, just throw the old one away and bring a new one. Actually, the whole Docker idea is based a lot of the immutable system pattern, server pattern. And what we suggest is stretch it from runtime to your continuous integration and delivery as well. Make your pipelines immutable, and if you need to build a promotion pipeline, do it with immutable and stable binaries. Again, this is all obvious. For our software, we do that, so why I even bother? Because with Docker, yeah, so this is what we need to know, right? This is what we need to do. We need to promote the binaries, and here are our quality gates again. And by now, you should ask yourself, what's up with the quality with gates with this guy? It's almost like that. I actually have a good reason to talk about gates, and that's because QA shouldn't test dev images, non-tested images shouldn't be staged, and of course, non-staged, non-test, or dev images shouldn't end up in production. So the quality, the rigidness, the hardness of those quality gates is extremely important. And your ability to build this protected area when you know exactly what quality of images are there are extremely important. And then you don't need to worry anymore. Your environments will only see what they are allowed to see and only will work with the images which are tested for that environment. So the reason I'm talking about all that is because with Docker, it's not so easy. And what we believe is a completely trumped up, and here's Trump again, limitation, much like this one. Remember this one? We have something very similar in Docker, and that's the Docker tag. One of the strangest things about Docker tag is that it should include the registry host right in the tag, and the delimiters between different parts of the Docker tag are actually slashes, which are also used for delimiters in the URI. And that's a very strange, artificial, and unnecessary conflict that actually makes it wonder, how can we have more than one registry per host? And remember, I was going all about those gates? Those gates, between those gates, we should have multiple registries. We have our dev registry, QA registry, staging registry, and production registry, all in the same host. But how can I do it when my tag includes the host name and nothing else? So the question is, here we go. We have Docker dev registry, Docker QA registry, Docker staging registry, and Docker prod, all under the same host. How the hell can I support it? We don't know why it is the way it is. What we know is how to work around it. You recognize this guy, right? The workaround around it is using virtual hosts and virtual ports, and/or. So we can actually invent here a virtual host or a virtual port that will, in fact, all it will be doing is rerouting the requests to this URL that we saw earlier. And you can do it with Apache, with Nginx, with the HA proxy, whatever HTTP server with rewriting capabilities you use. That's example of Nginx, and it does exactly that. So whenever a request comes to 5001, take the request path, whatever it is, add here v2 or v1, depending on the request path. That's the version of Docker protocol. And then rewrite it to Docker dev and add whatever other parts of the URL we got. And that's exactly how we can introduce multiple registries under the same host. Docker will conceive it as different hosts or different ports, but we will actually use different URLs, which are the right way to go. So I hope that makes sense. And that's what we do. That was what all our competitors do. And that's actually what Docker themselves recommend now, how you can manage multiple registers under the same host, which is insane, but it is what it is. Now, the other problem is, how do I promote? If the registry host and port is buried inside the Docker tag, that means that for changing them, I actually need to pull, change the tag, and push to the next registry, which, again, is a pretty stupid process, especially considering the size of Docker images, which are huge. And this is a very, very strange thing to do. But again, there are solutions around it. So if you have a tool like Artifactory or whatever you can find that supports multiple registries inside a single tool, you should have a REST API that allows promoting between those registries inside the tool itself. And we will take care of representing this image through something we call virtual repositories as a same registry, but inside we will actually have multiple, any number of them, and your tools, those are the quality gates that we spoke about, and your tools will only see this registry that they are allowed to see, and your provisioning tools, I mean. Right? And if you have some process that takes an image and rolls it out on a staging environment, it will only see this registry. And this is how we work around it. Now let's talk a little bit about when we learn about how it's done. Let's see an example of a pipeline. So let's examine one of the containers and see what we have inside. And that's a typical application, and not for Java. It will basically have the same concept, just that it will be something else inside. So we have our war file, which is our application file, and then we have a framework. It's Java application that runs inside a servlet container, so we have a JDK and a Tomcat, and we have a base image, which is some version of Ubuntu that we can trust. This one called Trusty, we have to trust it, right? As the name implies. So those are our layers. We have 3 or 4, if we split those to 2 layers, as the layers of our Docker image. And we will end up with 2 builds. First one will be the framework build. Framework build creates a Docker image that all our application images are relying upon being the from image for them. And we select one base for us, Ubuntu Trusty or whatever else makes sense for you, trustable base image. You add system dependencies like Java and Tomcat in our example, and you bring them from the source that you trust, like Artifactory. And the most important part is that you own it. It's your trusted base image that you verify and you know exactly what's going on. You can add additional configuration to it, for example, harden it. You can take this Ubuntu base image and harden it and then make it your own. But even if you have nothing to add, and you just love your 1404 as it is today, you still make your own image on top of it because you have to own it. And now you have your base. On top of the base, you add your application. You use the framework as your base, you run whatever application build you need to run. In this example, it will be a Java build that will create this war file. And then you add a single file to your base. Everything else is your framework. All you do is deploying your application. And then you're done. So here, the from is solid. You have your from latest framework. And then you add one file, the app release war, to wherever it needs to go. Now, there are 2 interesting parts in that. The release token, which means bring me the latest version. And here you should go, what? You just spoke about how it's not good? But that's our app. And it's in the right space between our security gates. If you have a pipeline for your app that you test without Docker, you will rely on the release area. If you always test your app with your Docker image, that will correlate to whatever stage you are in your Docker pipeline. And then you will have build file that rely dynamically on whatever repository you need to be their counterparts in the application pipeline. So you have that, and now we have testing. Who knows what that has to do with testing? Except of breaks during the testing. Anyone heard about the term sandwich testing? No, right? Yeah, me neither. But it's a thing, apparently. And we are talking about patterns, so here's another pattern, obviously less known. But there is a thing that it's called sandwich integration testing. And that's when we check in the same time both top-bottom and bottom-top at the same time. When we check 2 components together, how they play. And that's exactly what we have here. We have our 2 pipelines. That's the framework pipeline. That's our Docker-based image being promoted. And that's our application pipeline with our application image being promoted. And we test them across each other. So when we have an application pipeline that we need to test, we test it right from the development step with the latest known good production framework. It guarantees that when it's go over here, it still will work with the good known production framework. And when you change your framework, you will test it with the latest good known production application piece, war file for our example. And in that case, you always guarantee that your production application is still compatible with your new framework, right? Now, that cannot happen in our example, because even if you have breaking, non-compatible changes in both framework and application, you never test them, make those changes in the same time. And that's because the set of triggers that we have, which are quite obvious. Application build is triggered and tested with the latest good known framework every time there is a change in your application code. The framework tests, the framework build triggered every time there is a change in your framework code, right? So there is no way that you will have two triggers run simultaneously, bringing this deadlock. So that's another pattern of the set of the patterns that I wanted to talk about, the testing one, and with that, I think that's my message for you today. The conclusion will be release fast or die, and the more trust you build into your software, the faster you can go. So thank you very much, and I don't have any time for questions. Do I?
Yeah, we got about a minute, so if anyone has questions for...
Awesome.
I've seen a number of presentations around different ways to build and manage Docker containers, and all of you agree unanimously that all the other presentation approaches are wrong.
Of course.
So,
the difference between my presentation and all the rest is mine is the correct way to do it.
Exactly. Yes. But I guess my question is if, I guess, best practices as put forward by Docker start shifting, or you go from an environment where this approach is taken to something else, suddenly almost nothing along this axis then begins to be portable anywhere else. How do you, I guess, plan for, address that, or is that just out of scope entirely?
Well, no, so jokes aside about mine being the correct way, I think that what I try to show you today is don't do anything differently, right? And rely on the patterns that we know for decades, that proven, that work, do that. Although there is other paths of least resistance, and Docker pushes you to do things differently, fight it. Don't do things differently. Do the things the way that is proven how we should release software. And I don't see that changes anytime soon. And I also think that if it tries, just close it, that's fine. That someone will try to push you to other direction, think twice before you do something new, because this is the good stuff. Does it make sense?
Any other questions?
Thank you.